That is right. All right, so here is the last part of 8.5. A complex fraction is just another name for a fraction within a fraction. So what I would like you to do is to circle this definition, okay? A complex fraction is when you have a fraction within a fraction. This is going to be super cool because we're going to see why we've been doing everything we've been doing. Multiply, divide, simplify, add, subtract, all culminates into this one topic. So here we go. Here are the steps for simplifying complex fractions. You're going to simplify the numerator and denominator into one single fraction. Then that becomes division. Let me take you back in time a moment, okay? Let's write this down. If I had 1/2 over 3/4, okay, write this down in your notes. Squeeze it in here off to the right or to the left. If I had 1/2 divided by 3/4, we know we would change that to multiply by the reciprocal because that's division. And then you would cancel where you can, and that would be 2/3. And then you're going to simplify completely. So look at example 1. I have -3, so that's just one number, so it's golden. I don't have to do a thing with it. And then I have 5 over x plus y. Multiplying by the reciprocal only works with one fraction over one fraction. It does not work if you have sums and differences in the big numerator or the big denominator. Let me repeat myself, okay, because this is important. You can only change division to multiply by the reciprocal if you have one fraction over one fraction. It does not work like in example 1. I can't flip it and say x over 5 plus 1 over y. It just doesn't work if we try it. So, watch what we're going to do, and we're going to make a connection to what we've been practicing. I'm going to change y to y over 1. So I really want you to be focusing on what am I doing, how do I do that, and why. I need one fraction down in the bottom. I currently cannot add 5 over x plus y because they don't have a common denominator. So this is why you guys asked really good questions on yesterday's homework, and we tried to get that clarified. So what's the common denominator down here? X. So I just need to multiply the second fraction by x over x because the first fraction has the common denominator. So this is going to go -3 over 5 over x plus xy over x. I realize it's awfully tempting to cancel those x's again, but you understand you'll be stuck. You'll be right back to where you started. So here's what we're going to do. This becomes -3 over 5 plus xy over x. Now, -3 is not a fraction, but it really technically is because it's -3 over 1. So here we go. Now I have one number over a fraction, which that's okay. It's -3 times the reciprocal. If it helps, change -3 to -3 over 1. So you do technically have a fraction and a fraction. Is there any canceling we can do? No, no canceling. So my final answer is -3x over 5 plus xy. I cannot cancel those x's because down in the bottom that x is in a term. So, a complex fraction is when you have a fraction within a fraction. And our goal is to get one fraction over one fraction. So let's look at example 2. So Jacob, do I have one fraction over one fraction? Look, don't look at me, look there. Do you have one fraction over one fraction? Yes, I do. Yeah, Grace?
It says then state all the restrictions on variables. Are you going to do that?
We're actually not going to do that on the complex. We'll We'll do it on add, subtract, multiply, but we're not going to do it here. All right, so here we go. I have one fraction over one fraction, so that is terrific. So then I'm ready to take the top fraction, leave it alone, multiply by the reciprocal of the second fraction. That's called the divisor. Is there any canceling? No. So you leave it as 4 times x minus 1 over 3 times x plus 2. You can either leave it like this or multiply it out with the distributive property to say 4x minus 4 over 3x plus 6. Either is 100% acceptable. Yes.
The whole first process of it doesn't have y minus 1 or something. Or over. Does that make sense?
The y?
Yeah.
To make it y over 1.
And that one you didn't have to because it
It
was over.
was one fraction over one fraction. Yes. All right, so let's do a couple more here. Let's look at example 3. If I have 1 over x plus 3 over 5 over y plus 4. All right, I don't have one fraction over one fraction. I've got a sum in the top and a sum in the bottom. So watch what we're going to do. We're going to make this 1 over x plus 3 over 1, 5 over y plus 4 over 1. The common denominator doesn't have to be common to all denominators. I just have to get a common denominator up in the top. Then I get a separate common denominator down in the bottom. Okay? I'm not saying we have to get a common denominator everywhere. So, the common denominator up in the top, what would that be? X. So we're going to take and multiply by x over x. So that's going to give me, can you guys go with me? Can we maybe skip one step and make this 1 plus 3x over x? Can you do that? If that's too big of a jump, put the extra step in like I did above. You do what's best for you. I'm just making a suggestion that some of you can kind of make a leap. Down in the bottom, what's the common denominator? Y. So that's y over y. So I get 5 plus 4y over y. And you know what? I mean, I'm excited by just how many of you that I'm hearing, you know what to do. You know how to add and subtract. So here we go. This is 1 plus 3x over x times the reciprocal. Is there any canceling? No, bummer. So it does not matter if you put 1 plus 3x times y or y times 1 plus 3x. Typically, we put like a single factor in the front, but it's not wrong. All right, I'm going to pause, and I want you to try example 4, because I think you can. Cool. No, because there's still chunks. You can't cancel unless they're factors. All right, so see if you're with me here. I built a common denominator of x in the top, common denominator of x in the bottom. It's just a coincidence that the common denominators were the same. I can cancel the x, and I'm getting 2 minus 5x. Then do you notice 6 minus 3x can factor? So I should do that to see if it would keep going, and it doesn't. So technically, 2 minus 5x over 6 minus 3x would be an acceptable final answer because it doesn't go any further, but you should try.